Hello Professor, this is Group 4, the in-betweeners. The dataset we used in our project is the Seattle housing data. We decided to go with this dataset to gain some insights on the factors which affect the price of a house. There are 21,613 instances and 21 attributes in our data. Target variable is price. As a part of pre-processing, we have removed some of the variables like latitude, longitude, and ID, which have very less impact on our model. Then we decided to do an outlier analysis using box plot and removed some values from square feet lot considering the interquartile range. Now Mohit will discuss about the data model.
So to create data model, we divided our data set into 5 tables: 4 dimension table, 1 fact table, features, location, area, timeline. These are our dimension table, and fact table comprise of price. You can also see that dimension tables are connected to another tables which are data description table, and these table contain the description of various grade ID, condition ID, and view IDs. To implement this data model, we imported all the data into various tables which we created in HANA Studio, and a few of the tables look like this. For an instance, feature ID table has all these data, and data description table has this grade ID and description of the various grades. To build the data model further, we created attribute view. So for each dimension table, we created a attribute view, and one of attribute view feature looks like this, with the feature ID table in the center and connected to all the description table through text join. And to connect our dimensions to fact, we created a analytical view, a fact analytical view, in which you can see that data foundation layer contains of price as a fact table, and a star schema has all the attributes view of dimension tables. So we created all this view to achieve the data redundancy and to gain the data insights. Now we can plot our square feet living with respect to our measure, that is price, and see how it varies. We can also look at some of like a square feet living, and we can see that how the price vary. We can also create, for instance, the year of build, suppose this. So we can see that 2000 to 2008 has a high price range. So after creating this data model into HANA Studio, we connected our data model to predictive analytics and run one of the model, that is a regression. In regression, we selected all the significant variables and selected a target variable, that is price, and excluded all the variables like latitude, longitude, which are not significant. So the model output is something like this. So here we can see that the predictive confidence of our model is 0.97, which is a very nice figure we can see, and in the model graph we can see that there is a very less variation and price deviation. And furthermore, we can see the category significance, and we can see that having 2 floors in our house has a positive significance on the price. Similarly, we can review the R factor, R square factor for our model, and that is 0.68, which is quite high. So moving forward, after creating this model, we analyzed our hypothesis.
So our first hypothesis was that recently constructed houses would have much more higher value than the older houses, which hold true for most of the cases, but there were some certain cases where we found that houses with similar area but older when they were built, they had much higher value with the better grading condition. Our second hypothesis was that people tend to spend more on the houses with the more bedroom, but during our analysis we found that price depend much more on the number of bathrooms. So we can suggest that people like to buy houses with more number of bathrooms. Our third investment suggestion would be that properties satisfying these criteria, that is bathrooms more than 2.5, bedrooms more than 4, grade and other criteria, would give you much more higher returns than any other property. So this was our brief demo of model and analysis. Thank you.